Question: a vertical cylinder of radius r is placed on a horizontal surface. A small disc M is attached to the cylinder by a horizontal thread NB of length L naught, one end of which is attached to the cylinder at point B. The disc is thrown with an initial velocity v0 so that the thread starts winding over the surface of the cylinder. Find the time after which the disc will strike the cylinder. Okay, so here the thread is winding over the surface of the cylinder, right? So here we know like one thing, the length of the arc is h, this angle is theta, and this radius is r. So we can write basically the theta equal to h upon r, right? H is the length of the arc. So here when the disc will strike the surface of the cylinder only when the whole length of the thread is winding over the surface, right? So basically the length of the arc will be equal to L naught once it is completely like winded up. So in that case the theta will be equal to L naught by r. So that is the angle covered by the thread basically, okay, at the center of the cylinder. So now let's just see. So this is a cylinder here, and we are projecting this disc with the v velocity here, v naught. So basically like at any instant like we'll write the conditions. Okay, so let's say after t time, so the thread is basically it's like this, right? So it started like it's just winded somewhat over the surface. So let's say it covers some angle here, so that angle is let's say theta here, okay, and this is the disc, okay, which has some velocity v, let's say, at this point of time. So now if we talk about, and this angle is theta, right? Now if we talk about for small time interval, so in the small time interval it will cover some small angle, right? So let's call that angle is d theta, and this distance will be equal to v and dt, let's say. So that is the dt is the time interval basically from here to here, right? So now this v dt can be written as the length of this one. So we need to find this length basically, like this is a, this is b, and this is, let's say, p. So we need to find the length bp, right? So how can we find? So for that we need this length. So this can be written as, this is r, so this is r theta, right? And this complete length is L naught. So basically the bp length, bp is equal to L naught minus r theta, right? So this is the length which is like basically is covering d theta angle in dt time, right? So now this L naught minus r theta is this length, right? Okay, so here v dt basically we can write the length of the arc is equal to L naught minus r theta into d theta. So that can be written here. Now we'll integrate. Okay, now from here like t equal to 0, the theta is basically 0 because it is here, t equal to 0 here, and when it strikes the surface, so let's call that time is t, and when it strike the surface, so like whole length of the thread is winded over the surface, so the theta will be L naught by r. So now we'll integrate here. So it is like v into t is equal to, here we have L naught theta minus r theta square by 2. Now I'll put the limit. So vt is equal to L naught square by r minus r by 2 into L naught square by r square, okay, and so that's it. So vt is equal to L naught square by r, and this is L naught square by 2r. So here we are getting L naught square by 2r only. So the time which we'll get from here, that will be like L naught square by 2rv, okay. V is basically will be the V naught. Okay, because in the question that this is thrown with the initial velocity V naught, so that the thrust are winding over the surface. Okay, so here that V naught will remain constant, so we'll take V as V naught. Okay, so that is given. Okay, so fine, so that is the answer. So in this time, like, the disc will strike the cylinder. Okay, that's it.